Hello everyone, thanks for joining. This is this is not my architecture. This is actually built on serverless. Too many stuff happening. So if you're new to this series, this is an advanced series for Twitch that we use the same tools you are used to it. Let's say an IDE or a language or a test framework, whatever, and we're trying to build something using the same tools you have. So then we kind of learn together, and we also get help from the audience because we don't know everything. This is live, so expect things to go wrong. So let's see how we go.
Yeah, okay, let's do it. So hopefully I'll help you out. I'll ask header questions throughout, and hopefully this will be very useful to all of you.
Absolutely.
All right.
So if you missed the first part, this is an application that does something like this. So that's a special thanks for Asher for actually building the diagram for us after the first episode. So I really want to thank you live. All this application does is a crypto service. Like think about a PCI environment where you need to have some data out of your JSON, out of anything that needs to be encrypted. So you simply implement or deploy a simple crypto to encrypt part of the data that's incoming, and then you just pass that along to the rest of your backends or data flows, you name it. So all that application does is have a /encrypt and a /decrypt that sends a post. Each of those are Lambda functions that actually ask for an encryption key and to do that. So we already coded this application in the first part. We covered the IDE setup, the Python setup, all of this stuff. So you can actually capture that on the previous episode.
And which service are you using to encrypt using the Lambda function?
We're using a service called KMS, so Key Management Service, that does all the heavy lifting for us, storing the keys, encrypting, decrypting, all this stuff.
And how are you going to call those APIs? Are you fronting the Lambda functions with any service or?
Sure. If you see that on the left-hand side, you can see /encrypt and /decrypt. That's going to be API gateway doing the job for us.
Right, okay.
Right?
Okay, I knew that, but
Guys, you never know. So this episode, we're going to jump straight to tests and write all the tests for serverless. And then we're going to build a CI/CD from scratch using new tools that we got. In the first episode, we didn't have SAM CLI, and we didn't have a lot of tools that could help us make this episode even easier. So what we've done now is we already have the code right here. So if we already have the code as before, we separate front end for back end, and we're gonna start populating the unit test. So by the way, once again, the code is already written. So we may even find some bugs as we write some tests, because that's actually one of the main purposes.
Absolutely.
Right? So let's see how this actually works to kind of visualize this whole diagram.
Absolutely.
And then we go to the next steps.
So I'm really interested to see how that looks actually. So what are you going to show us exactly right now?
Sure. So in the first episode, we deployed a sandbox application to. When I'm developing, this is my style, by the way, and you don't have to follow this. What I do is I like to have my own developer stack, where I can just play around with things. Sometimes I use the console, try to use SAM and infrastructure code as much as I can, but sometimes you just want to do something quick. So I use my developer stack to do all my stuff, and I call this a sandbox. So what we're going to do now is we already have the backend deployed, just to show you the UI, how the end goal looks like.
Yeah.
And then we go code.
Awesome.
Right? Because talk is cheap in that sense.
So we're coding this, and we're deploying this, and we're testing that locally, right?
Yeah, absolutely.
Awesome.
So this is how the application looks like. As you can see, I'm really like a pro in design. It took a long time actually to position those things in CSS and Flexbox. So if you're a pro, I would love some lessons on that. So what you actually do here is you can say any data you want to encrypt. So let's say, this is a secret. What better than this, right? It could be anything. It could be a JSON as well. So if you click encrypt, if it works, it works. Okay. We can see that we got this message already, which seems like a space 64, because if we actually return the encrypted data, we cannot serialize this type of thing. So we kind of covered this before.
Right.
If I click and show output, to kind of give you a hint on how what was the return from the API gateway.
Right.
So essentially, we got data as a key from JSON, the data in there, and we also got all this information about HTTP headers, cores, all of this stuff.
Absolutely. So if you had to summarize, what did we just see? We saw the front end making a call to API gateway, and then we saw a Lambda being invoked that actually encrypted that text you inserted into the...
Exactly. I like to dive deep into things. I like to see where things break, and particularly how things work behind the scenes. So if I try that again, let's say try a laugh as like a Brazilian laugh. I just click in encrypt, and you can see that we have made 2 requests to a /encrypt. This is my sandbox API gateway. And you can see that first we actually made a request as a pre-flight course. Just leave that because we're sending that from localhost.
Right.
And then we also made a second request once the course accepted, which is API gateway said, okay, I'm fine with you sending those requests from localhost.
Got you.
We send the data through post, and then we got, I'm not sure if you can see it from the very bottom. You can see the request payload was data, and then the JSON, the data inside the data.
Got you. And you also mentioned you have a decrypt function, right? So
let's try this out.
Look at that.
So this is potentially, if we finish early, or if we actually have enough time, let's say an hour and something, we could potentially even write integration tests. So let's copy this. We go to decrypt, and now we click in here and pray, and
so what's that? That looks weird.
Hang on a second. Let me try it again. Let me try a Brazilian laugh. Copy all this. Go to decrypt, and
it looks like you're encrypting something encrypted.
So let's have a look. So let's do it again. So if you click in network. Now that we have this encrypted piece, let's try again. So if you click in network, we have all this. Here we go. Okay. That's actually that's my bad. If you can see that the button actually says decrypt, but we're actually calling encrypt. Okay. So we are encrypting the encrypted data. So sorry, let me fix this very quickly. So if you go back to...
You could go on forever, just encrypting and encrypting and encrypting, I guess.
So I'm using Vue.js because obviously it's the best front-end framework in the world. If you like React, we can have a chat later. I don't have a problem with that. So if I find this stuff in here, actually it's here.
So
this is really simple. Like when you're doing this from serverless, your front-end is going to be as simple as making this particular REST API call. Of course, it could go even further and do more complex things. But for now, let's go back, encrypt very quickly. Let's say actually, this is my secret. Encrypt that data, copy this, decrypt. Fingers crossed.
Fingers crossed, yeah. Oops. Hold reloading, or...
Is that cached maybe?
Maybe it's cached.
Yes, it was cached.
Okay.
So here we have another problem. We have me making silly mistakes, and now you also have actually browser cache. So here we go. So this is the application. So this is just the backend code already there. If you are interested in actually seeing the final code, we actually already open sourced, as we said on the first episode, but we're gonna do better this time because we have a higher bar. What we're gonna do is, once we finish our tasks or unit tests and all these pieces, we're gonna make a pull request to Sam repo and have Sanaf and Jacob, who hopefully are watching this stream, and have them to approve if the test pass, right?
I can approve anyway. All right, so you also mentioned that we're gonna have a look on how to deploy this, like from end to end, from committing some code all the way to production.
Yeah.
What are the kind of services that come into play?
Good question. So let me show you this first. I try to avoid slides as much as I can. So just to promise you, you can see, I'm not lying, you can only see 2 slides in there. So if you are not familiar with CI/CD, for now, what you need to know is this whole length of actually getting something from source, getting this source code and build something, and potentially even running some tests as part of the build, unit test or something. And then you test something more heavily. Let's say you deploy a stack and then you run an integration test, a smoke test, you name it. And then once you're very comfortable with this, then you deploy this to production.
Okay, so first locally, we'll use all the tools to test everything locally, then push it and see that being deployed in production.
Exactly.
All right.
Exactly. So in this, we're actually using a bunch of other services, code pipeline to generate a whole pipeline, code commit for source code, but it could also be Jenkins or GitHub in that scenario, code build. I'm going to show you a fantastic way of doing code build locally now that I'm loving it.
Cool.
Thank you, code build team, for making this awesome tool. And then we use SAM, which basically does our infrastructure as code, and deploy.
Awesome. So I guess all this will make sense. So
yeah. So there was one little problem though. For me, initially to build all of this stuff, usually you have CodeStar, which is a fantastic service to begin with a CI/CD if you've never done this before.
Sure.
But I had when I was working with a few customers in particular, and also my own taste sometimes, I already have an application already developed. And I may want to customize that pipeline in multiple accounts and do federation, do all those sorts of stuff.
Right.
So I wanted to find a way more flexible.
Right.
So here's the first announcement for today.
Okay.
So of course you can use CodeStar, and I totally recommend CodeStar. Go for it if it's the first time you're doing. But if you already know pipelines on AWS really well and you want to customize all of them and go deeper on that sense, here's the announcement. So we announced something called SAM CLI last time. Actually, in between these episodes, we announced SAM CLI. If you never played the SAM CLI, that gives you local development. It gives you all the stuff you need.
Right.
But it implemented something really new called SAM init.
Gotcha.
The SAM init is the magic we need to give everyone a pipeline in a much nicer and easier way. Let me show you this first. If I actually go back to my terminal in here.
So are you saying there is like a SAM CLI where it gives me like the scaffolding of my entire CI/CD pipeline, right?
Yes.
Okay.
So I could simply say, let me know if it's actually too small on the screen. I could say SAM init -- runtime Python, and I could say Python project, or I can say let's say SAM init -- runtime Go, and then specify Go project, and so it go for Java, .NET, yada yada, and so forth. Right. This scaffolds me a basic unit test, everything I need to deploy and go forward. We didn't have this before.
Gotcha.
Before we used a project called Cookie Cutter and create an advanced way of doing this.
Right. Now, so it's bolted down to the SAM CLI.
Exactly.
Just run SAM init.
Exactly.
Get started really quickly.
So if you already have SAM installed, 2 tips. One is there is a Easter egg in the -- help. So if you do a -- help under init,
right,
you're gonna find an example on how you can use SAM init with the normal built-in templates.
Gotcha.
And how you can also create your own template to do whatever you want.
Gotcha.
So in the first episode, we used this one. So if I were to run this command now, we would be able to create an advanced scaffolding template for Python with SAM, with safe deployments, with X-ray for distributed tracing, and a lot of other things, including Makefiles and all this stuff that developers love.
Perfect.
So this is to recap very quickly on the SAM CLI. There's a lot more other stuff in there. There's validate now. You go for it and give this a try. But the announcement is, now you got this application. We got an application already there.
Yeah.
How would we add a pipeline to our code and actually get this out of our way so we could get some of those stuff?
Yeah, absolutely. And that's what I was interested in. I'm happy to code the Python application, but I really need help to test it locally and give me all the tools deployed in production. So yeah,
makes sense.
Let's do that.
Okay, so here's the announcement. And the same. So if you go to this, if you go to this particular, so you can send that to the Twitch chat if you want. If you can actually. So if you go to this particular repository, this was open sourced about a week ago, if I'm not mistaken. So if I copy this URL, you're gonna see the magic now.
Okay.
So let's go to Visual Studio Code. We are on the backend folder, right? You can see my backend code, my 2 functions. My unit test is nothing there yet. And if I do this, sum init -- location, and I paste this URL, here's what we're gonna have. We're gonna be asked, what is the name of our project? So we're actually building a simple crypto service, let's say on Twitch.
Okay.
Right? So I could do this, and they asked me, what is the source code you want to use?
So now you're building this scaffolding step by step, essentially, right?
Yes, and even better than that, I can say I could use code commit or I can use GitHub. To make things quicker, I'm gonna use code commit, and that's it. Now, if you actually look about this on the left-hand side, you can see we have some new instructions that have been created for us. We now have a build spec for building our application both locally and to the cloud by running code builds. We also have a pipeline.yaml that all that picture that you saw from the PowerPoint gets automated, get out of the way.
So it kind of combines all those services like code commit, code build, CloudFormation, code pipeline, everything is in that template, right?
Yeah, exactly. So if you actually go over here and look up in the pipeline.yaml, you're going to see instructions of what's actually happening, all the services that we are using. You can see separation between what's the source. That picture that you saw, it's actually using some ASCII arts because I'm a kind of fancy boy. And you can see the build artifacts, the build part of it. And also sometimes you want to see exactly how we can modify those pieces. Maybe I'm not running Python, I'm running Java. So what is the official image? Here's the link.
Got you. So code build, essentially, whatever the environment, you have an image to allow me to essentially build my project, whatever the runtime.
Exactly. And then you'll be able to have the cache feature already enabled by default with some tags, and the entire pipeline we discussed now codified to CloudFormation in something that we can repeat. Including if you want to extend this to add more options, here's the link for you and you can go and do whatever you want.
That's absolutely great, actually. So what's left now? Was it like, how do you go about it? What's the next step? So I have the scaffolding, I have all the services lined up. How would you essentially continue?
Sure, absolutely. So what we're going to be focused now we're going to start coding it, right? So of course you have some pipeline instructions if you once you read afterwards, it kind of explains you how to run the pipeline. We're going to do that in a sec. But for now, what we should be focused on is on the build spec.yaml. First, we need to understand how we can run a build locally. And then we can start writing our test and run that build locally until we say we are confident enough that the build runs locally. And therefore, we also run successfully once I push my pipeline.
Gotcha. So last time I checked, code build, I could only run it server side. Is that like a new thing?
Yeah, it is a new thing. So in fact, if you go to code build images, this particular GitHub here, you can see that there's a new folder called local builds, which basically we published the code build agent. So all you need to do is to run this Docker pull, and then he explains to you how we can run this using Docker. You can use both official images from code build, which you have to build yourself. Again, everything is in the script instruction and in the blog post. But you can also use any Docker image you want as well.
Got you. So again, I get different Docker images depending on my runtime, and the same paradigm exactly as it would work server side.
Yeah. So let's give this a try. Just say a hello word, and then let's see. So I kind of put a comment in pretty much everywhere in the documentation about the build spec and what you can do with it. So let's say we just say testing the build, right? And then we want to generate a artifact.txt. Because normally in the build, you get something from source code and then you do it, right?
Absolutely.
Cool. So I already have some template package command, all of this for you. But for now, we're just gonna comment this out because we're not gonna need it. And we're gonna have this artifact.txt and we want to upload as an artifact, as a build artifact. So that's it. I even have cache enabled, I have all these pieces, but that's it. For now, that's what I need from the build spec perspective. Now we need to learn, how do I run this thing? Because normally I would go and just use the shell script that code build now provides you as a helper.
Right.
But I find that understanding the underneath of stuff and how things run is actually more helpful for now if you're beginning with this.
Absolutely.
So let me show you this now. I already have a snippet that will do all this stuff for us, and I'm gonna walk you through now. So let me just change this to shell.
So that Docker command you run there, that's essentially the local agent for us to run the code build tests through the build spec YAML. Is that correct?
Exactly.
All
So
right.
what we need is that we need to run Docker. You need to have Docker installed, and you pass the Docker socket to the Docker container for agent. So then code build, we run a container to run the build.
Gotcha.
And then you specify what is the image. I already have an image already built. So if I were to use check my images, I have lots of those, and I have Python already here. I already compiled because I don't want to stop us from writing the test. Just want to show you very quickly, and then I want to write code. That's what I'm going to do.
Absolutely.
And then you specify a artifacts folder where as one code build runs, it generates a zip file that goes to S3.
Gotcha.
Because we're going to run locally, we can simply specify a folder.
Gotcha. So the target is up to us to define. We're running code build locally.
Exactly.
I see.
And then you specify where the source code is, or in better words, where in your file system is not only your source code, but actually your build spec.yaml.
Gotcha.
And then lastly, you can also pass the AWS configuration, AWS credentials to the build. So inside I could just probably list a S3 buckets, or when I'm going to run some package afterwards, I can just pass my -- profile. Once I know it works, I should remove and then work to the pipeline.
Gotcha.
That makes so much easier. So thank you, Sabine. Thank you, everyone from the code build team. This is amazing. So let's try to run this first. I just kind of fixed the path. So we are in a different path now. So we are over here. So we're gonna switch this very quickly. And this should be this. Let's see if there's any fat fingers already with me. So now is the show time, and let's see if that works. So let me just double check. I'm really paranoid of checking things. So simple crypto service, part 2, backend artifacts. If you remember, we don't have the folder called artifacts over here. So that will be generated for us if the build succeeds.
Gotcha.
So let's try this.
So we're testing now locally and see how our application will respond.
Yeah, of course. When we finish writing our task, we want to make sure we can run this build over and over and make sure it is repeatable. So if you try to run this now, let me try to increase this. You're going to start seeing the code build is now running and it's getting all of these pieces, and it completed it. You see, we wrote the fastest test ever.
I see code 0, that's good news.
So if you see, we probably remember that we have some echoes like testing the build, and we also had an artifact.text, and you have more echoes in there. For now, we're just doing echoes, but still works.
Yeah, I mean, it makes sense. The build spec is not built out yet, so okay, it runs. Good start. Let's build out this build. The build spec.
Cool. Happy to copy and paste this command for you afterwards if you want, but it's actually on the GitHub repository. If I click on artifacts now, I now have a new folder, artifacts and artifacts.zip.
Right.
So if I try to say what's in there, I could run a command called zip info artifacts.zip. And we should have an artifacts.text. I don't want to unzip, just to prove the point that anything that you pass as an artifact inside the build, in other words, any files that you generate, folders, everything, that local build, including the real code build service on AWS, you would get that, put into a zip file in whatever you define.
Yeah, and now it's different because it's locally, we just send it wherever we want. The real thing would send it into an S3 bucket essentially.
Yeah, all right, cool. Let's see, any questions on the chat that we should stop for now? How do we, or can we get started and start writing those tasks?
I think we're good to go. Actually, maybe start with having a look on the build spec. That's where we start, or?
Okay, cool. So let's stop this for now. We for now, I'm gonna leave the build spec alone because I want to write the tests and use my power of my IDE. And same again could be Cloud9 and everything else. For now, because we started using Visual Studio Code, I'm gonna continue Visual Studio Code. So what we need to do is we need to create a test file, right? So let's say we want to test the encryption part of it.
Gotcha.
Of course, normally when I'm actually building something usually I try to separate the function that runs my business logic into a separate file, and then my lambda is just a lambda.py type of thing.
All right.
So I prefer doing that way. But for now, because we don't have much time, what I need to do when I start writing tests, but by the way, this is the way I think. It works differently for everyone. I like to split so I can see exactly what I need to mock. And also I need to know, I like to do this, actually. Given a context, when something, and then expectation.
And so if I were to ask you this unit test that you're trying to build, what is the aim? Which function are you trying to test? And how does it fit into the overall sort of story?
Sure, absolutely. So for the unit testing, we want to make sure that we don't care about the integration. What is it that I don't care if I actually go through my code? I don't care what is the response of, I don't care if we're able to call kms.encrypt, in fact.
Right.
I want to mock as much as we have with integrations, any calls that we make elsewhere that we're not necessarily responsible. I want to mock all of this and make sure that at least my code, if I run through all of this, it works.
Okay.
So think about doing a base 64, which is here, manipulating some data, looking at the return of the data. This is what we care, because sometimes you make a change in the code, there's a typo in there, and you want to catch those silly mistakes as quickly as possible. Maybe the return should be a string or this type of things.
And would you say that's like the best practice? Every time I want to deploy a Lambda function into production, using all the tools we mentioned before, would you actually go and write a unit test for that? Or?
Yeah, absolutely. So normally this is what I do and what I also recommend most of the customers that I meet in person is focus a lot on your unit tests. And one thing you're going to figure out, and you're going to prove the point in here today, is unit testing or testing for serverless doesn't change. It is exactly the same thing. Okay. Because in fact, Lambda makes it easier, if anything. You have actually a Lambda, a function that receives an event and a context, and then you can mock those out if you need. And then that's it. The only thing that really important, because I got burned in the past, before even joining AWS, it's important to know that trying to mock, when you see this kms.encrypt or multiple other services, if you try to mock the real services, in the sense of trying to make stub or make real like a fake API that you call it, at some point you're going to realize that this stub becomes out of date, or if you run some other open source solutions, you say they work halfway through, you get Dynamo, but you don't get Dynamo streams. So I would suggest focus on your unit tests. Right? First, when you go to the integration test, run that against the real service. So get your source, build, run the test, run security checks, everything else that you need. If that fails, you don't waste the deployment cycle.
Right.
And then once you're sure that that your code is intact and it works, you deploy it, and then you can start actually hammering with your API and everything else to see if it really works.
Right. And you can also in the whole pipeline you generated, where is this test going to be executed? Is it like the gamma stage or the beta stage? Where is it executed?
Sure. So remember actually that particular picture that we normally going to have like something like source and then the build. The build is going to pick up as an input artifact what we call in Git the head. Right? So that's going to be the Git repo. And then this test is going to run in code build. That's why we run that locally to make sure it works. And then if we run, and let's say we deploy something, let's say beta, and then we could run another build step in here that actually is going to run our integration tests.
All right, so we just add one more step into our pipeline, and run our integration tests, but that might fail even before getting that from the unit test.
Before getting that. Yeah, you want to make sure that you are as comfortable as possible. You test every single coverage before even deploy to production.
All right.
So in that case, it could be a Lambda function. It doesn't even have to be code build. But I'm actually a really big fan of code build, especially now that we have the local agent. So I will just use code build for almost everything now.
Okay, awesome.
Okay, so how do we start? So we need to import this code base first. By the way, before we start, any questions, anything, anybody joining now that you need to do a recap or anything?
Yeah, that's good. Yeah, probably I need to send some links out there. But you're cracking, don't worry about that. You're already coding and stuff.
Cool. So here's what we need to do. I need to first import my code. So I need to import what I need to have. I need to import it from encryption. I need to import the app.py. That's what I need, right? That's what I care for. And then I actually have already installed PyTest, which is a test runner for Python. It, for me, is the best ever out there. And I also installed a mock plugin. So if you're trying to follow with me, or at some point, or if you're trying to do that afterwards, all I need to do is just run a pip install pytest and pytest-mock, and you have the tools you need for this particular session. So how do we test that first? Let's say we test encryption. First, we start something really silly. We're not going to try to optimize the fixtures and all these advanced features. I want to start simple for now, and then if we have time, we go optimize these pieces and such.
Absolutely.
So what we need to do first, we need to receive a mocker.
Okay.
Right? And then we go for the given, when, and then the. Again, this is what I like to do. You don't have to follow. So what are we trying to test here first? The encrypt function receives a key and receives a data, right? So if I try to code here, that will be, let's get a return.
Okay.
And then we should be able to, we should be able to run encrypt. And that encrypt should be able to pass a key, and the key should be some key. And then the data should be some data, or something else, whatever we want.
Gotcha.
Right?
Gotcha.
The problem is if we run this is gonna fail really badly, because it's gonna try to call KMS, and that's gonna fail.
Yeah.
Right?
Yeah.
So what is our context? So given KMS is mocked, when, let's say, given I have, the opposite. Given I have some sample data, when KMS is mocked, again, not integration test, then I should receive a base64 return.
And that's, why is that? Is that like the specification of the actual API of KMS?
Let's have a look at the code.
All right.
So first we run a kms.encrypt, and we get that data, and because it's encrypted data, it's going to be full of actually XX01 type of thing. We can't serialize this.
All right.
So what we need, also because this returns as a byte, we need to base64 this, and once we base64 this, we return.
Gotcha.
If you remember from this particular, when we try, let's say, encrypt, you do something like this, you should receive a base64.
Yeah.
But if you try to just do a base64 decode, you get the whole encrypted string. Just nothing there for you.
Yeah, gotcha.
So first what we need to do is so if you look at this part of the code, we try to encode, but before we encode the string, we get the return that came from KMS.
Yeah.
And then we try to get the key called ciphertext.
Gotcha.
Right?
Yeah.
So that means we need to return that data. So if we just return a normal mock, our code is gonna actually fail right here. So let's send some basic data first. Let's say KMS data, something like this, and that's gonna be the dictionary. So we should have this ciphertext. Let me just copy this because I normally have a fat finger, and what we need to have in here is the data that comes from KMS is going to be bytes.
Gotcha.
Or even if it's not bytes, base64 encode string is actually an alias to encode bytes.
Okay.
So that has to be bytes.
So you're building essentially a dictionary, and you have to convert that in bytes for KMS to be able to do the work with it.
Yeah, so let's do that now. So first, in Python, if I want to do something like this, I would just do something like this. Say, I don't know, my secret. I'm really not that creative right now. So in theory, if we actually get this ciphertext, we are sending that ciphertext, then they should be able to see as a byte, and they should be able to do an encode string.
Gotcha.
So far, we should be able to get this piece work, and you should be able to return. Of course, it's not going to go through this exception, but again, step by step, baby steps.
So for those joining now, if we take a step back, just to explain where we are. So on the right hand side, we have the encryption function, Lambda function, that we demoed a few times. And on the left hand side, we're building a unit test that we want to inject into our pipeline and see the whole thing being deployed with serverless services into production. So this is where we are. Right hand side is Lambda, left hand side is unit test, right?
Right. Cool. So let's remove some of this crap. But the problem is now, if we try to run our code, this encrypt isn't really mocked.
Right.
So what we need to do is we need to mock this. If you're not a Python developer, even sometimes Python developers find this ridiculously crazy difficult. So don't worry if you don't understand everything for now, right? So what we need to do is we need to mock this, and we need to remember that we're passing a plugin called pytest mock.
Right.
And then we can just say mocker.patch.
Got you.
And then we have to pass the object.
Okay.
This is where I got really frustrated when I started doing tasks, because I didn't understand the scope, and that was really difficult for me to know when to patch, when to mock, this type of things. So what do I need to mock? I need to mock the KMS
call.
The KMS call, the method called encrypt.
Yes.
So if we try to do app.encrypt, trying to mock this, it's not going to work, because that's going to try to mock the result out of this function.
Gotcha.
We need to mock the .encrypt from KMS, from the client. So what do we do? Remember, where does this KMS come from? This is the first question to be asked, so you understand the scope.
Yes.
If you scroll up, you're going to find that we have some session being created, it doesn't go to the internet, and then we have the client being created over here.
Yes.
So we need to get this variable, get this as our object, and try to mock its method called encrypt.
All right.
So let's try this. So we're going to do app.kms. It should be actually be auto-completed. I don't know why it isn't being auto-completed. Let me just double check one thing. Yeah, so anyway. So we mock this, and now we need to pass as a string what is the method. So the method is what? Is encrypt. We pass this,
right?
And then
we need the return values, right?
And that's exactly it. We need to pass a return value.
All right.
So let's do this first. Now remember that we created the first kind of a data that we want to respond with. So now we just pass KMS data.
Gotcha.
And we have our stuff over here. Let me just explode this a bit. So don't worry, let's go through this. So first I create a simple dictionary, which is only the data that the rest of my code cares, because that's the code that we're gonna do a base64 on top of it. But if I try to just pass the data and pass right here, whatever data, that's gonna fail because we're using KMS. And again, this is not an integration test. I don't care about KMS.
All right.
So what I do is what we're actually doing here is we mock this KMS that's being instantiated in my code. I don't want to break the instantiation of my code. If I need to, then I can add more sophisticated testing. But that's not for today. And then we get this from the app that we imported our code.
Got you. Yeah.
We mock the encrypt, and then we pass this value, which means when this particular piece of code runs, actually the return is going to be this.
Right. Yeah.
And then hopefully we should be able to encrypt that just fine, and we should have no problem.
So if we stop our unit test here, what would be the coverage we have so far in the Lambda function? Until which point have we covered, essentially?
Sure.
If you had to assume, right?
No, absolutely. We're gonna show that graph later. If you haven't seen coverage library before, actually, when you see, so this is something we did before. As we try writing those tests and trying to run some coverage, we're gonna start seeing those greens and where exactly we are running. So what is the part that we're gonna go through? We are only gonna test the function itself called encrypt, the try piece, and also the encrypted data.
Got you. So we're gonna cover the first bit of our Lambda function. It's a live coding session, so I know you've written the whole thing before, but
it's fine.
Let's focus on that.
Again, we're not gonna. So the point here is that whatever you're testing, this is your business logic. This is what you're testing for now. Lambda itself is just gonna be something, just gonna be an event really that's coming. So let's give this a try. So let's see if I can do this from an editor. Otherwise, I can jump to. I need to discover the unit tests. No tests have been discovered. What are you saying? What are you drinking? So let me have a look. I have my encryption here and I have all my stuff in here. So maybe I need to go and I need to do that by hand, which is fine as well. So one piece of advice if you're new to Python is scope again is everything. If you look in here, we have test, unit, and then you have test encrypt. If we're trying to do a front encryption import app, that's gonna fail. There's no encryption folded over here. Right. So if we actually execute PyTest from the main structure, from the main folder called backend, then we should be able to get that folder called encryption, and then get the application called app.py.
Got you.
So that's a scope thing.
Got you. It's all about taking the right modules into the test, right?
Yeah, exactly. So let's give this a try and let's hope for the best.
All right. Okay, fingers crossed.
Again, we're not even doing an assert. We're just testing if we can run that. So what is it happening? So let me see in there. So it complains that I have no tests run. Oh wow, what is it? What is this? What is this sorcery? So if we try it again.
Alright.
Okay, because I didn't have any assert and that's why I wasn't. I started to get nervous here. Oh my god. So this, for now, this kind of proves that we're getting there. We can even go further. Let's say we make a change here. We're not passing as the bytes.
Okay.
So we should expect to fail over here.
Got you.
Right? So I just want to do a debugging very quickly before I start doing debugging in my IDE. It should be there. I don't know why. If we try to run it again and we pass and we just do this, well, it fails because we got a type error because it's expecting bytes and a string.
Right.
So, but if I pass...
And how did you know it was expecting bytes in the first place?
Cool. Maybe because I've done this before. Maybe because I've done this before. But also because I've done base64 for quite some time in Python.
Right.
And when you actually look into this and try to import base64 and you do a help base64 encode string, you will see that it's an alias to encode bytes. Which by interface, when you're going to go in deep into encode bytes, it expects a byte.
Alright.
Okay. So we got this, but what I wanted to show you is how mock is actually working. So then we can move on and do other things. If I do a --pdb, which is actually going to run my debugger, then we're trying to figure out how to get that in IDE afterwards. If I run this, you'll see that my IDE actually stops where my code actually fails. Again, I don't expect you to be an expert in PDB. That's quite a hardcore. I know, Jacob, if you're watching, you're going to be laughing your ass out right now. But what's important is that you can actually have a look into what kind of a data you have in there. Remember this piece here that we are running?
Right.
We can see what was the return. And you can see the ciphertext, my secret, and the blob in here. Which means our mocked worked as we expected it should work.
Absolutely. And just to elevate the whole take a step back, so if that test failed in your pipeline, essentially what would happen? What would that mean essentially?
Sure. If that test fails on your pipeline, that would essentially fail the whole build and stop your entire pipeline.
Right, okay.
Which is exactly what we want. We want to make sure that when we do this, we don't want to get caught in silly mistakes after we deploy that.
So that's like super important, right? This could catch maybe an error in production, users not being able to use the application, and so on and so forth.
Yeah, exactly. Which is also cool, and then we can also even do other things like I think assert. Let me see. No, it's not over here. Because we know exactly that our base 64 is running, we can even just try to say assert is actually run with these particular arguments, etc. But I'm gonna do a little bit more complicated. I could do this because that's not hard enough yet. So we could do this. We could say expected, right? And I could do exactly as we are doing over here. Actually, in fact, I'm gonna copy this line. But we're gonna change this a little bit. So I'm gonna say this, it's gonna be this.
Right. And you need to return that value from KMS, right?
Yeah. For now, oops. That's why I love all linting. So ideally, this should work. What we're doing here is, first we're actually doing the normal thing, the normal as we're doing, but before we actually run this, we could do a expected over here. We could even bring this over here now. And then we can say, if our base 64 worked and our KMS really worked in that particular line and nothing really created exception or anything, then it's just base 64 in our code now. So I'm just testing that particular area before we go to integration tests. So now, hopefully, this should work. So let's see if I can do a discovery now, because I like to run. I can't believe it. Can't believe what happened. If you actually know what's happening, please let me know. I have no idea why this is actually failing. So that should be in the fault code backend. No task discovered. That's silly. Okay.
So let's build a build spec. I mean, we could maybe spend like 10 minutes trying to debug here, but
Fine.
Trust me.
Okay. So it works as we expected. So that part is fine. But we also need to cover the fact that maybe either this piece or this piece could fail.
Absolutely.
It's actually not the best exception in the world. I would love to fix it now. Maybe we fix it later. But we need to make sure that we couldn't really encrypt that data. Maybe there was an exception.
Gotcha.
So what can we do here is I like to actually create particular code, multiple functions, very tiny, to just test that particular piece so I can see what happened.
Right.
So I could test no exception, right? Whatever. And then I could get this now. And then I can have another one saying bad key. Let's say with exception.
So that's like no key, bad key.
Actually, better, no bytes data. If we know that if we pass with no bytes, that's
it will explode.
Yeah, that's gonna explode anyway. It's not gonna be camera, it's gonna be our stuff in here. So let's say that for a miracle that a contract has changed. Of course, it's not gonna be a real word in that scenario, but again, so we're gonna do this now, and we're gonna mock this, and we're gonna remove these bytes, and now when we test, that's gonna fail. And we expect that to fail. So what we do, we have something called, I think it's called raise exception, raises,
pytest.raises.
I don't know, I think just because I changed virtual environments, my ID is not autocomplete. So let's do this, pytest raise exception.
Okay, some live
Python it should be python.raises, something like this. Here we go, easy. pytest actually .raises. So if we do this, we expect a exception. Ideally, it could be a value error or it could be anything. Actually, let's fix our code. This should be a value error, by the way, because it's a value that's causing a problem, right?
And that's That's how you find the bugs in your code, write the test, then go back to your
Yeah.
Lambda. and change
Yeah,
it.
more or less like this. So we expect to create an exception and go over here, and that should raise another exception.
Right.
Maybe I'm thinking that the wrong way, the other way around, but let's try. So if we try now and say app.encrypt, we've actually copied this right here, easier. Let's try it again. No, first I need to import the library. So is that gonna work? I was expecting someone in the audience actually telling me no, that's why autocomplete wasn't working.
All right.
So no problem, let's import this now. And let's try again. And
Awesome. All right.
now we got even better. We even fixed our own kind of basic or really bad kind of exception in there.
All right.
Cool. Well, of course, I could do even better. I could create another exception just for KMS, client error type of thing, and go even further. But for now, we got this. So we could continue on that particular Lambda handler and we see how we go. I want to show one first before we go there. I want to see how the coverage looks like for now.
Yeah.
And then let's build the build spec to run it locally.
Absolutely. Yeah. So this is kind of a sample how you run this unit test. I would be really interested to see the code coverage. What's covered, what's not.
Cool. Okay. So I have to install something called PyTest Cov, which is a library called coverage. But then when I install the plugin, it does everything I need. So what we need to do here is we need to do the normal Python stuff, and then we can pass, I think it's, let me say, I don't remember the exact, I think it's called Cov, and then we have Cov, here we go. So we can do just this. So I don't need a PDB, so let me just remove this. By the way, I'm only running that command to actually write coverage just for encryption folder and give me an HTML.
To interrupt you a little bit here, some people are asking in the chat if they can find this code somewhere or...
Sure. So you will be able to find this code over here under the Serverless Application Model repository. There is an examples where you have a bunch of other examples in there, and the one that I built a couple of years ago is called encryption proxy. So now we're extending this. Once we finish this episode, we're gonna push the test over there. Awesome. Well, this is if Sanav and Jacob actually allows us to actually merge this pull request.
Well, you know, we can always say video code and push stuff, right?
Okay, cool. What is weird is that it says that it's not collecting anything, which is really weird. I don't know what's happening. I think I changed too much in my setup before. I wanted to make sure that I started clean and say collecting no item. So let's see if I have this folder. Yeah, I don't see why PyTest isn't recognizing we have a test in there.
So what you were looking at there was essentially an HTML page. The code coverage would be absolutely visible.
Yeah, which is also weird because my IDE isn't actually starting recognizing that as well. So ideally, I should have test folder, and then I even have a PyCache. That's crazy. So I have a test. Maybe that's it. Maybe it's the name of it should be test, and because that's the prefix, I think it's working now. Let me just have a look. Let's see. So try it from this, discover, no test discover. Yeah, of course it's gonna fail, dude.
It's test encryption.py, right? Is it the name of the file maybe?
Yeah, so the name of the file is right, which is weird because, well, if anyone on the audience actually knows why, let me know. But that should be it. So I'm passing verbose, very verbose, and if I have any print, I want to print that. So the test works. I just don't know why that coverage So it's covering now.
You know how that works, right?
I think this should be part of your computer,
It will be live coding if everything
your
works.
computer science degree. I have no idea why it works. I have no idea why it doesn't work. I don't know, and we keep shifting. So let's have a look. We have all this stuff in here. That's a lot of stuff.
Some live debugging then.
Yeah.
So that's quite
So
interesting.
let's click on the encryption.app.py, and that's what we want, right? I don't want to see what's not missing. I want to see what's covered. So does it all make sense now?
It makes sense. So you just wrote the first test, the first few lines of tests, and you can see that being covered here.
Yeah. What's important for us is that we wanted to cover the encrypt.
Right.
Accidentally, we covered other pieces, which is what we expected. We wanted to go through all of the code, all of the initialization, and then look at the function itself, which has our business logic. If encrypt doesn't work, then, well, everything else is not going to work.
Got you. And now that you know what you cover, let's say we cover, say, 100%, right? What would be your next step? How would you basically put that into your workflow as a developer?
Sure, absolutely. So let's see what we need to do. So first things first, again, this is going to be, we're going to dash through this. Don't worry, we covered all of this in the first episode. But what we need to do is like this. We know that our code, our encryption, works really fine and we can encode this, but because my virtual environment already has Boto 3, that's going to work. But that's not necessarily true for a build environment or whatever environment.
Right.
We need to install all those libraries. So,
Absolutely.
because I don't want to keep into build, pip install all the yada yada yada. I have a Makefile. I love this Makefile. So it's part of the advanced cookie cutter, so I can get from there. So let's go to the build spec. What do we need to do? So I'm just going to close this for a bit. We need to installing system apps. First, we need to install some dependencies.
Right.
Because we are using Makefile, we actually use rsync, which is not available in the code build image.
Right.
Maybe we could make a pull request for that, but for now, it's fine. So this is my background as sysadmin, so don't worry if you don't understand this piece for now.
So what are you basically trying to achieve? Prepare your code build image to essentially run the tests, build your code, and test it locally, right?
Yeah, so first I need to install the basics, which is like, apt get, upsync, etc., rsync, not upsync, etc.
Right.
And then I want to make sure we can do a make clean. We want to clean the entire environment. Again, that syntax is going to be, it's actually covered on the other one. Don't worry. I want to make sure that we start clean. We have no residue or no app file, temporary file. We don't have anything. Right? We install this, and let's actually copy this because I like to separate into echo. This is the beauty of this show on the advanced series because we are showing you I'm going to show my own opinion on things, how I like to structure. Right?
Gotcha.
So clean up, old setup, test runners. And then here, I need to install my dependencies, right?
All right, yeah.
So how do I install my dependencies? So
So if we take a step back, just for people that haven't used, this is the actual configuration file that code build uses, right?
That's right. What we're doing right now, if you just joined the stream, is buildspec.yaml is what you use when you're building a build project using code build in the cloud. But now we can run code build locally,
right?
Which is awesome. So that's exactly what I'm doing right now. I want to make sure that we have enough confidence that this will work for us. And once we build the pipeline, this should also work for us.
Awesome.
So now I have this and I need to build my developing environment, or in that sense, I need to install my dependencies into the code and make sure that everything works.
Gotcha.
So how do we do this? So we will do this. We will do service and then we do the encryption.
All right, so is that building the actual Lambda function, the code that does the encryption essentially, right?
Yeah, essentially we're going to install all the dependencies that we need. If you look at the file, if you haven't noticed this, if you look at the coverage on everything else, you have a pip file, which is a new way of doing some of the dependency management in Python. And I'm going to install Boto 3. And when I'm doing dev, I can do pytest mock. And by the way, let's fix this. That should also be PyTest conf.
All right. Okay. Good point.
Cool.
Yeah.
Okay. So we do this. We're gonna install this now, and then if everything works as we expect, we should be able to run our tests, right?
Okay.
So the problem is I also need to install my dependencies. So in this case, I need.
Are you gonna do the same thing for decryption as well, or just?
I'm gonna do the same as for encryption. For now, we need to install pipenv because this is the new way of doing things.
Okay.
For now, we can even skip all this and do something more basic. So for now, let's do this for now. We're gonna do this pytest, pytest.mock, and pytest.coverage.
All right.
Okay.
Makes
For
sense.
now, we have all the tools we need to run the tasks, and our application has all the dependencies we need. Next, we run our tests, right?
Absolutely.
So test runner for encryption or whatever. In this case, test runner.
So what you did before, where you used essentially PyTest to run the test you wrote, you're now putting that command into the pre-build phase, essentially.
Exactly. So what I need to do is I need to run Python,
Okay.
the module pytest,
Right.
and then we need to pass the folder where our tests are, which is tests,
Got you.
right? And then in here, I need to pass, I can pass some extra information in case I need that, right?
Yeah.
And with this, hopefully, we should be able to work it out.
And what am I expecting as the output when you run? When you use that file in the Docker image provided by GoDbuild, what am I expecting? Yeah.
I'm expecting to see a past as an output,
All right.
and I'm expecting to see a access status code as 0.
All right.
Anything non-zero is a problem.
Cool.
Cool. All right. So let's try this out. So let me see if I'm not missing anything. I'm installing system dependencies, rsync. I'm running make to build that. I'm actually running make to clean up the whole piece. I'm installing all the dependencies for build encryption, and I install all of my tasks in there. Ideally, this should be something like this, but that's for later. Okay, we got this, and then we run Python and pytest, etc., etc., etc. Cool. Just in case I'm not missing anything. Now I'm gonna run code build locally, and everyone, fingers crossed. Let's see how we go. Right? So code build CLI. Actually, I already had that. Let me go back in here. Yeah, sorry, I had that already. So we could run this now.
Okay.
Let's see if that works.
A bit of hesitation there when you press that
Just kind of a waiting and then seeing.
All right. Exactly what we're expecting to.
Yeah, let's see. And we got some error with our artifact not being there, and because we're not creating the artifact.text. But that's okay. Let's see if we failed on the build. Actually, no module named build by PyTest, but we installed that. Oh, actually, it failed to do an update. We failed even before this. We failed at installing system dependencies. So option -t required. So apt-get update. I accidentally added a -t. It was supposed to be a Y for yes. This is live. This is what you expect, right? Don't expect things. We're not gonna copy paste things. We're trying things. We're trying to learn together. So let's see. Now I'm expecting fine. You run too quickly. I know apt-get takes a while just to run that.
Right.
So I just add -QQ to doing a quiet mode. I don't want to see that whole stack trace. Because otherwise I'm not gonna see what I need to see. Right?
Got you. Yeah. Yeah. You'll never be able to see that typo, right?
Okay. So we passed that point. We installed rsync, and then we are still getting issues with the artifact, but that's fine. What else have we What else have we done?
Have you put wipe the rsync as well, maybe?
Yeah, so that's fine. I'm actually getting something else. Syntax error unterminated code string. So that's new to me. Oh, gosh. I feel like we need to write a linter for the basics. So it's actually missing over here. So by the way, let's create an artifact. Let's say, just to make it, I don't want to see errors. Okay. Okay, cool. Run it again. Let me just double check if I'm not missing any other errors. So we have missed the quote end quote string. The good news, we're doing that locally. We're not waiting in the cloud, waiting for that stuff to happen.
Absolutely.
So I have my I have my double quotes now. So let's see if I'm not made any silly mistake. One thing which is interesting, this is a kind of a curiosity. When I started programming, I was from ops background and became a dev security type of thing. And I always thought that developers would have this enlightenment. They would come in here and say, I don't need Stack Overflow, I don't need Google, and they're just typing everything they needed. When I started doing that myself, I was just like, wow, I feel stupid, I feel like silly. I don't remember like PyTest all raises this library, etc.
Right.
And then I was like, wow, that's actually the normal piece. And then, you got this image where people have this enlightenment that they never actually fail on something. And in fact, sometimes it can look as stupid as just kind of a double quote.
Well, it's again, it's live coding, man. Don't be so hard on yourself.
Oh, but it's pretty cool. So here we go. We actually got a problem there. This is I wouldn't say a bug. This is the way Docker, we're not gonna go explain to you very, very deep in this, but because of the way code build mounts the volume and kind of a mount in different places, when PyTest runs, it runs an integrity check to see if the previous source and the mountain actually have any checksum works fine, etc.
Right.
Because we run a make clean, but that make clean isn't actually helping us here. If I remember correctly, the clean doesn't delete the PyCache folder.
Right.
So this is a very nasty little piece of buggy that I don't expect you to solve on your own. Again, I solved this, and I'm gonna make this as part of the Makefile in another pull request.
Okay.
So how do you whenever you get this, so you're gonna see the error over here. Again, this is really nitty error.
Gotcha.
You remove PyCache or PYC, which is a pre-compiled binary for Python bytecode in that case, not binary. We need to delete this. So first what we need to do is I could just type this command, but I have autocomplete, which is nice.
Right.
I need to find all the folders that have PyCache in there and then delete it.
Gotcha.
Right? So what I need to do is something like this. Trust me, I'm not gonna delete my entire file system. So I need to get everything that's PyCache.
And now run it.
And I need to do this.
And would you do that again if you weren't testing locally, or does this have to do more about the local Docker image that you're working in?
That's mostly local. When you're building, first you're not gonna add your PyTest cache and all these cache folders and files to your code repository. You don't want to see that stuff. Right? But because in this case it's mounting as it is, I need to clean that stuff out.
Absolutely.
So if that works. It's still, even if it's complaining about no such file, he actually deleted all this piece. So I'm gonna make a change over here. And now we shouldn't have this problem anymore. That should be covered by make clean.
Alright.
Okay. So now, once again.
Let's see.
Alright, let's see.
And essentially this command, right, where you found the PyCache modules and you deleted them, you can put it anywhere within the build spec, it will be executed. But you wanted to package everything up into make clean, is that what you did?
Yeah, exactly. So normally when you run things locally, your task runner will create a cache. So it runs that more effectively the next time it comes out.
Gotcha.
So what we want to avoid is the fact that once you are ready to go, you want to make sure you can publish all your Git commits to a Git repository and have all the stuff in there. You don't want the task runner's cache data. So let's see. It's just complaining that because of this, no such file directory is actually complaining. So you know what? This is not gonna happen in the real world afterwards, just on my machine for now. So I'm gonna delete this I'm sorry for this back and forth. I'm gonna run this now because I don't need to run tests locally anymore. And then you remind me, please, that I need to run this before we go. So we have nothing in there. So I don't expect this to fail anymore because I really want to get this working. I know you might be pissed already, and I know you are impatient as me. So yeah, fingers crossed.
All right. Yeah, I mean, it seems like you've removed all the source of errors. So.
Cool. So yeah, this is a nasty thing that I run that yesterday when trying to work things out to make sure that I have not missed anything in general. And it was really difficult to find out why that was the case. So when we run that straight into code build, that wasn't the problem. So we got to figure it was something locally, and that's why.
Right.
Yeah. So it's mostly due to the PyTest runner cache. So let's say this. Let's run this. Fingers crossed. And we run, and sounds like it worked. Right. So let's have a look. Yes, it passed. That's what I was looking for. I had that stuff already. Which is even cooler. I could even run that again. I'm not going to run that again. I could run that again and include the coverage for HTML and get that as an artifact and see how my coverage is going.
Okay, yeah. So what we did before, you can get it as part of the code build process. That would be perfect.
Yeah. What's even cooler is I could, and now that I know it works for that particular unit test, I could go in here and say, I want to also build the decryption.
The decryption part, yeah.
And I want to actually package my code with SAM and create as an artifact. And if that works, well, everything else will work.
Got you. So now we're getting closer to the build spec it would use in the actual pipeline, right?
Yeah, exactly. So let's do this. Instead of actually continuing the unit test for now, I could go in for forever and for ages, but I'm also conscious about the time. Let's create the pipeline with scaffolded.
Right.
Get it ready. And then make sure that our package works locally.
Right.
And then if it works, then we just go and ship that and see how the deployment works with our build.
Absolutely.
Okay?
Yeah,
so hopefully everyone agrees. Let's see. Okay. So how do we go from here? I already have my tests. And remember that when we run that SAM init command, we created a pipeline instructions. I'm going to delete this for now. And in that pipeline instructions, that shows you the end goal. This is our end goal. We're going to have a pipeline that have the source, build, beta, gamma, and then production. And then we have a manual approval as well. This is what we want. We already have CLI. We already have the CLI installed. We have all this stuff already. We need to create a new stack, right? Remember when we say that? If you're not using Python, or if you actually want to kick off the pipeline from a different branch, click here and see the instructions. For now, that's what I need. So let's go in here, and because I have multiple profiles in I have multiple AWS accounts. Again, I'm not paying. I want to make sure that I can create this stack. So first, what this stack is going to do for us is just going to create this skeleton of our pipeline. It's not going to do. I need to start AWS. Actually, sorry, I have multiple virtual environments as well. So we should be able now to. Here we go. We create a new stack, and now we should be able. Let's have a look at CloudFormation.
Just to step, just go with that. Where did you find that template, the pipeline YAML that you use into the create stack process? How did that get generated?
Sure. So if you missed the first part of it, is we run a command called SAM init, and we run this little piece over here. So if you want to generate right now and you have SAM CLI installed, that's what you need.
All right.
So essentially, we are running SAM init to scaffold something from us.
All right.
And instead of scaffolding a SAM application, Python, Node.js, etc., we want to scaffold a custom template.
Gotcha.
And therefore, we pass the location.
All right. So this pipeline.yaml will create all these different stages. You showed my commit repository, my Git repository, the build spec YAML, everything. And all I need to do is go in and modify that, right?
Yeah. The power of this is like this. In the meantime, the pipeline creates. You as a customer, here's my advice. You can fork this, right? You can fork this repository and add your own best practices, your own way of creating pipelines. And then all you need to do afterwards is just do some init dash location, and there you go.
Gotcha.
So if you have never done cookie cutter before, you will see that the cookie cutter, this whole template is like this. You have a cookie cutter.project. These files, they look familiar.
Yeah.
So now if you click on pipeline.yaml, if you change this file, then you should be able to generate a pipeline that looks like closely to your environment.
Like have different stages, different manual approvals, parallel steps, different building services, like Jenkins, for example.
Exactly like this. Remember when we said about choose GitHub or code commit?
Right.
All of this stuff is in here. If I would have chosen code GitHub, I would have all of this stuff that I need to have. Okay. Enough of talk. We already have our pipeline. We just created a pipeline, and the only thing we care is we should have a Git repository that we need to push our code to. Right?
Can I just have a look at the pipeline just to see if it's the same as the image?
Of course, let's have a look. I think I have this code pipeline. I have it. So I have simple crypto service Twitch. You see that it's failing.
Why is it failing?
It's failing because I have no source code. So first I need to push the source code.
That's fair enough.
And then once I get in there, it kicks off everything I have.
Alright, so what you were developing, like the unit test and the build spec and everything, now we're pushing that and we're gonna see stuff working, right?
Exactly. Remember, everything we've done locally. Before in the previous episode, we run Lambda locally and everything locally. So this is expected to work. So how do we do this? So I need to connect to the repository, right?
Yeah.
So in the outputs, you're gonna see a list of things that you have. S3 bucket, yada yada, blah blah blah. So if I copy this, I already have my credentials. I don't want to get this in our way in this episode. So if I go over here and I delete that stuff, I first need to initialize a Git repository.
Right.
So I'm not gonna add a front end in there for now, just a back end.
Yeah.
So now we need to do a git init.
Okay.
Easy.
So now you're gonna connect this to remote, right?
Yeah. Right. So I have all of this stuff in now, and now I need to add a remote. And then in this case, I'm gonna say origin.
Right.
Okay. And then I do it here. This is git command, so you don't have to worry about it. If everything works correctly, I should do a git remote VV, and I have this. Now it should be in there.
All right.
So in theory, if my code works locally and everything works locally, I should be able to simply do a git add, commit, and then push.
Gotcha.
But there's one more thing to do it. Remember that we commented the package pie.
Yeah. Well,
so this is important for us. We need to, once we run our tests, we package our code, right?
Gotcha.
We need to make sure that we be able to package this using SAM so that we are ready for deployment. So the next phase of beta, gamma, and prod should work, right? So you see that there's a variable in here that gets injected through CloudFormation through the pipeline.yaml. Because we create the S3 bucket for artifacts, we inject into the build, and then we can go into
Gotcha. And then there's an output template there, the package. Where is this gonna be put into the build spec?
So now I have to go into the artifacts.
Right, okay.
And do this. I don't need the artifact.tags anymore. I can remove all this, like this stuff. I don't need it. And in theory, I'm actually good to go.
So then Sam will take the output, package.yaml, and deploy our stuff. Right?
Yeah, exactly. Just because I don't want to make another mistake, let me just have a look at the code and see if everything else is fine. I want to see if I don't have any, because we started from where the episodes finished. I know we had some cores and we tried to see that we don't need this data. This is crap. So we can remove this stuff. Everything else looks okay. I don't even need a cores, so I can remove this because again, we're not going to run API Gateway locally.
Alright. Okay.
So everything else looks fine. I'm okay with printing the response for now. And this shouldn't be this should be a value waiver, right? But again, we're going to fix this later. Cool.
How about before you run it, in the actual pipeline, are the cores configured from an API gateway perspective?
Good question. that's gonna fail.
Yeah.
Actually, I forgot this. So the pipeline.yaml has all the stuff we need for the pipeline. Good catch. So we need that into the template.yaml.
Exactly. Yeah.
Which is essentially the core of our application. Is our application, how we define our application.
So just for my understanding, this actually creates the API gateway resource, right? And we need to configure, right?
Exactly. So we need two things: pipeline.yaml to create the pipeline structure, CI/CD, build, etc., etc.
Right.
And then from there we get the Git repository, we push, and then the pipeline kicks in.
Gotcha.
And then we have a template.yaml, which is our application. How should we deploy our application? What runtime it runs? How do we do all this stuff?
Right.
You see that we have encryption and we have /build. This is what our make build is doing. It's doing everything in there.
All right. So creating this directory structure, putting everything in the build, and we're grabbing everything from there.
Yeah.
All right.
And then we do everything from here. We create our KMS key that will be passed as an environment variable for a Lambda function, so we can encrypt and all of the stuff in there. Okay, we got all this stuff done. Perfect. So it looks good. So let's actually add all this stuff in there, except I don't want this PyTest cache.
Yeah.
So I'm going to use a tool called gitignore.io, which I love it. If you haven't used this, go try this out. I want to say I'm developed from Mac OS, but sometimes I can use a Windows or I can use a Linux. I use Python and I use Visual Studio Code in this case, but sometimes I use Sublime as well, and sometimes I use Vim. Okay.
All right. Okay.
So anyway, just to let you know. So we got all of this git ignore already done for us. Now I want to say git ignore, because I don't have any, and I have everything in here.
Okay, that's pretty good.
So let's say if I have cache, I have a PyCache over here. I don't want this. I don't want this byte optimized.
Right.
So let's try it again, and I don't see this stuff anymore, which is super cool. I don't want to see the folder artifacts as well, because that's what we done locally, right?
Yeah.
Okay, and we got this, and then it's fine, everything else. I don't think it adds any harm. Okay, so we got all of this, and now I can say feature, kind of a conventional commit, and I can say ship it.
All right.
And then I can say push origin, because that's where to the branch called master. That's where our pipeline is going to run. So that's
what are we expecting now? What am I going to see? So this failed state, would that change in my pipeline?
So now, because now we just pushed that to the Git repo, we should expect to see this repository in there with code commit. I'm gonna show code commit first, so I expect to see that code over there. So it's over here 23 seconds ago. Perfect. And now I can see everything we need in here.
Awesome.
Right?
Okay.
Unless I missed something really bad again, so apologies if I missed that. I always do these things. And I should be able to go to pipeline
and see things run it.
Yeah, so that might take a little while now. So what's going to happen now is the code pipeline keep periodically from time to time say, hey, is there any change in that particular branch?
Right.
And if there is, this red is going to turn blue, and then we should be good to go.
All right. Okay. So we'll play the waiting game here until code pipeline picks up the change from code commit, and there you go. Okay.
It's blue.
All right.
Because this is going to take a while to run, I'm going to tell you now the underneath of stuff. First, any questions that you have, ask now.
Sure, yeah.
Okay, something else. So what I want to tell you is that remember that in the pipeline, you have an input artifact and you have an output artifact. So from the source is the code. That's gonna become an output artifact for build, right?
Absolutely.
And then from build is an input artifact, and then generates that zip file that we can deploy that stuff. Absolutely. But the problem is, how does CloudFormation know the file, the package.yaml, so I can create a stack and everything else?
Right.
If we go back to the pipeline.yaml, if we look up for package.yaml, you see this. Build artifact as zip, which means it's the output of code build.
Gotcha.
And then you can do a column and access what's inside that zip. So we are interested in the package.yaml so CloudFormation can go and deploy.
Right. It would grab this CloudFormation deploy, it will use that file and we'll sell our assets.
And now because I know all these pieces, I could go even further and do another stuff that if you haven't seen this project is freaking amazing. So I could do this. I could do CFN linked and then I could do CFN linked template.yaml.
And will that validate my entire template?
Check this out. In the meantime, we're running all this. So I want to show something cool. So let's say I'm going to install CFN linked, right? I install this, and I always install the Visual Studio Code extension.
Gotcha.
So if I go in here, again, nothing stops me from doing a SAM validate. But let's say I'm going to change this to Python 3.6 yada yada. You can see that this has become red. You must specify a value for this runtime. Right. So I can get this, and I can have linking for my SAM template, local API gateway, local Lambda function. I can also have my code build running locally now for all of this stuff I want to do.
Gotcha.
And that gives me confidence that everything should be in their best of their intentions to actually, not best of their intentions, should be at the best of their shape to actually be deployed.
I'll agree with you. Everyone will do unit tests, test everything locally before they push into their pipelines. Right?
Yeah, it's important to know that infrastructure as code is code. So we need to lint for this, we need to check for these things as well.
Absolutely.
So CFN lint is a new project that if you haven't seen this, it should be called CFN lint. It's on GitHub. It's actually this project over here. That gives you even an extension for your IDE that and also a CLI that you can run, and you can do all of these pieces. It can save you hours. I had a discussion on Twitter the other day that we're trying to figure out why was it causing circular dependencies, etc. So this kind of helped me a lot on trying to figure that stuff out.
Absolutely, yeah.
All right, let's have a look. So the build worked, which means the test is working, which means our local code build worked exactly as we expected.
I was worried about that, but since we tested locally, or it's pretty cool. So
let's say now all we need to wait is actually for have our first deployment for beta, and then to execute. If that's complete, then we go to our front end, just to prove the point. We can point that beta to the beta endpoint, encrypt and decrypt, and that will be our integration task because we only have 25 minutes left.
Absolutely. So what is beta trying to create? What are all the resources that are being created right now?
Sure. So remember that template.yaml that I told you that this is where my application is?
Right.
This is what I care. What I want to do is to have a single template and have the same environment deployed in multiple environments as close as possible. So I don't have to come with the excuse, well, it works in dev, but it doesn't work in beta, it doesn't work in gamma, yada yada.
Okay.
So we have exactly the same thing being deployed.
So different instances of the same things are being deployed into our account.
I don't want to use API gateway stages. I actually want to use the best practice. I want to use an API for dev, an API for gamma, and yada yada yada.
All right. Okay. Perfect.
So this is gonna run over and over in all these pieces. I can even go and say add conditions. If the parameter is stage and is production, then add a safe deployment mechanisms like Canary type of thing. So I could go further and make it even more complex and such. But that's gonna be a talk, and we don't wanna,
it's a part 3 type thing, right?
Yeah, we don't want to. For now, we don't want to spoil. Obviously, we could also go back to our unit test, and I find unit tests very addictive. I like gaming stuff. I don't know about you, but I could actually come in here and say, split this stuff, and I can even start adding, the whole Lambda handler in here. If we were to run unit tests to complete this now, what would we need to do? I don't have a KID environment. Remember that in the SAM template, we actually get that inject. We don't have that.
Yes.
So we will need to run, again, the mocker, patch, object. we get that app.os, right? And then we would patch environ, and then we return a value, say, whatever key is in here.
Right.
So that's how we would go. We would go and mock the things that it's not gonna help us now because we care about the code, and we will find that this is a bug, this shouldn't be here. Like all we are testing here is when you receive an event, you receive like a body, and then in there you receive a data. Actually, that should be here, which is actually the data or whatever you want in there. So this is the API gateway integration. We're only testing if body is actually, if the body isn't there at all, which means someone called through SNS, which it shouldn't be there. Right. But this is also wrong because we're not saying that, we're also testing for data, but we're not testing if there's no data, if there's actually no.
Okay.
So we will need to test this in a better way. So I'm gonna fix this later. I'm not gonna fix this now.
Two-stage test, essentially, right?
Yeah. So as you write those unit tests, you start saying, well, your code doesn't make that much sense. So that's why you get the value out of it. And the integration test, in that case, it would be another code, another build spec with, I could have a browser in there, I could do everything I want, using Splinter, using Selenium, using so many other good tools, but we only have 20 minutes, so it's not gonna help. So let's see how we got here.
Well, we got deployed. All right, so next step is seeing what's deployed, taking the new API gateway endpoints and putting those into our front end, right?
Exactly. So we go here, in the meantime, Gamma is being deployed. We go to CloudFormation details. We have, you see that the name remains consistently. So now I can see exactly that this is beta.
Cool.
And I can go in outputs and I can see that I have an encrypt URL over here. So what we want to do?
Let's not encrypt. Let's not decrypt decrypted it.
No, let's do this. And I go back to my IDE, and let me just don't save all of these pieces. And I want to go to encrypt.vue.js, again, fantastic framework. And I don't want to use the sandbox right now. I want to use beta, right?
Right.
So if I copy this now, I have a different endpoint.
Absolutely, yeah.
And I want to go to decrypt now, and I want to do the same.
Absolutely.
And I want to say this is the gamma, right?
Yes.
But I want to use decrypt. I want to say this is the new URL, and to not make that silly mistake again, we change to decrypt, right?
Yeah.
Okay. So we go back in here, and we have our new stuff already working. So it has hot reloading. That's why I love this thing.
All the cores are configured for localhost, I remember. So
yeah. So let's see if we're really testing that, and I'm not lying to you. I want to see from the Google Chrome tools if that is really what it is. So let's try to make a.
All right. Same.
Right. And then I can see that I make a request. But if you look at that closer now, you see that that's PM7SS74.
Shall we switch to the API Gateway console? I really want to see that.
Yeah, absolutely. Yeah. So you can see that this is the different endpoint. And if I go back in here, I can see that PM7SS, this is the real, it's not the same part.
Right.
So, but hang on, we need to test both encrypt and decrypt.
Absolutely.
This is our rudimentary integration test that I'm ashamed to call integration test. But still, let's call this decrypt, and I get this working.
Awesome.
Let's go to the pipeline. Let's go to the results. Let's have a look at how I can get here. I think I didn't add. I added API getting here. So we have a bunch of APIs here. Don't worry. I'm interested into.
You've been working hard.
I've been playing around. You can see that if I look at in here. I should never go here. Simple crypto. You see that I have a beta and now just a gamma. So this is what I want. I want to have an API for different environment, a lambda for different environments. So I know exactly what is happening.
So the gamma go deployed as we're speaking, essentially.
Exactly. So if you see the cores is actually being added as we were expecting. If I try to go over here and try to find out, is the headers correct? Yes, they are. and they
Yeah,
only accept my
localhost.
local host. If I change the port, that's gonna fail.
All right.
So
So let me get this right. So basically, you use some init, you generate the sample pipeline YAML, and this created all this stuff for us, right? All right. Okay, that's pretty good.
cool. That's it. That's it. That's it. The rest. So if we continue in here, we have the gamma, and now the gamma has been deployed. We can test the gamma as well. But now I have production waiting for our review.
Yeah.
Do you want to say something because you just reviewed everything worked?
Yes. I'll approve.
I have the power. Cool. So we got this now. Let's test gamma just in case we're doing something crazy, right?
Right.
So we tried the gamma. We got the same. We got a different API URL. Let's test this. Let's change our front end to actually reflect this. Again, this should be automated to build, etc. But again, we're not gonna do this today.
Yeah.
I got this. If you're interested in knowing how to automate an integration test, ping us over on Twitter or, well, you already have our Twitter, so it's fine. So that should be decrypt, and this should be beta, and this should, actually no, gamma, sorry.
Gamma and gamma, yeah.
Oh, I did it wrong, so this should be beta.
This is gamma.
Okay. This is my OCD playing.
Yeah.
Okay. All right, so we got encrypt, we got 9 AON, and we got 9 AON into decrypt as well. Cool. Go back in here, refresh, call this stuff in here. Let's say I have another Brazilian laugh, and I click in here. We got this.
It's really fast, isn't it? It's like, boom.
Yeah, exactly. And then we click in decrypt. And by the way, this is the first time we're calling. That's API gateway calling a Lambda function, downloading the code, doing everything we need.
Absolutely.
And
of course, saying like it's the first time we call this endpoint, right?
Yeah,
essentially.
Exactly. And then if I keep calling it, you see how much faster it is.
Yeah.
And of course, I can do a proper benchmark, and that could be a step in the pipeline. I could run an integration test with another build spec, run a API test to see if really encrypts what I'm sending and decrypts what I'm saying. And I could have a load tester to run a bunch of data to be encrypted and see if the performance degrades. So then I could see a regression test done properly.
Right.
Yeah. And all of this in a pipeline, right?
Right. So
cool. Okay, so let's have a look at the last one. We have prod being deployed. We just created the change set, and now we are executing. If we go to our cloud formation, you will see that I have my beta, I have my gamma, and I have my prod. Which is super nice because I can go in here and destroy beta, and that's not going to impact anything.
Yeah, absolutely. I like this decoupling of different API for different stage in my pipeline. So.
Exactly. So that's it. We can wait a little bit here with a bunch of other, a few more minutes and see how this goes. Let's actually see how far along are we. So if it's not that far along, we can wait a little bit and test that too. But this is really it. That covers unit testing, testing serverless applications. You can see that it is no different from any other application. In fact, it's even easier because your code base is so much smaller and so tight to that particular business logic that writing tests, we wrote that live. I mean, lots of stuff could go wrong. Wow, we kind of did. Yeah. But you could actually see how fast it is. And now the code build allows you to run it locally. It becomes a much smoother experience in every possible angle.
I tend to agree. I really like that you can test the whole build locally, right? Not just do some local testing with Lambda or API gateway. Now you can do the actual build locally. So.
Yeah, our production have just finished. If we now click in outputs, just to give you, not to give you that doubt, we can go again and then do the same exercise and call this prod. And now I have this, and then I can go in here, prod, and decrypt. And then again, you can see there are completely different endpoints from one another.
Right.
And now I can go to simple encrypt, again, refresh this, just in case I have any cache working on me, and I can say, you build, you run it, right? Everyone's responsibility. So that's the secret. So I click in encrypt, and I got this fine, and I click in decrypt, and I also, yes.
All right.
Here we go.
It looks like it's running even faster every time you put it in there. All right.
So that's it really. If you really have a doubt that I popped into my head is that how would I run this sum package even locally to make sure it works, right?
Sure.
How would I do this? Even easier. You see this, that we are injecting this build output bucket.
Right, okay.
We have permission to do this on that bucket because I'm admin on that account. So I could go in here and say, environment, the key is build output bucket.
Okay, and pass that instead into the package.
Remember in our pipeline instructions to finish this off is I give you a command in how you can run the creative stack, and I also give you a command in how you can check it out some of those resources that we are creating. So if I just do this in my terminal, I'm interested in the build S3 bucket. You see this big name?
Yes.
Or long name?
Yeah,
So
absolutely.
we're gonna copy this
And put it into an environment variable.
and put into there. Now we are ready to run code build locally without changing anything we need in here. And then of course, when we run that inside code build, we won't want that. It's just to make sure everything will work as we expect.
No, that's quite cool actually. You can now go your local testing a step further as well.
Yeah.
So if I ask you just you showed quite a lot of information and different things on how to do your entire pipeline. If we were to take a step back and look at from like a 5,000, 10,000 feet, what do we achieve today? What do we do?
Sure. What did we do today? Go to the pipeline and let's see what we did.
All right.
First, we had already an application, an existing application.
Zoom in a little bit.
Sure.
My eyes are not very.
Okay. Yeah, we're getting old. So what we have in our place is that we had already an existing application.
All right.
But we didn't have tests for this.
Right.
So before I've done all of these pieces, we wrote our unit tests locally.
Yes.
At least to make you to know how it feels and how it experiences writing unit tests for Lambda, which doesn't change. We run a template to create a pipeline for us, all of the skeleton that we need.
Awesome.
Once we've done this, our tests were being generated, but we couldn't really kick off the pipeline because we didn't have our tests, and we weren't really sure if the application was going to work or not.
Yeah.
So we built all the tests first, and we run the code build locally using the new code build local agent.
Awesome.
Once we run all of these pieces, we made sure everything was ready, and then after that, we got this template passed to the confirmation, say, hey, tests are working, linting is working.
Right.
The SAM template also looks good. I don't have any concerns with that.
Gotcha.
Go ahead and deploy this stack. And
Right.
that is deploying the template YAML that we had done in the episode number 1.
Gotcha. So API Gateway, Lambda, all these are being deployed through that template YAML.
Exactly. The only thing we didn't do today because of timing is actually write down the integration test and everything.
Okay.
So if I were to write an integration test now, if we had probably an hour more, I would actually run this. If you haven't seen it, it's really cool. And if you don't like PyTest, you also should check out Splinter. I've done this for a much larger project that had like thousands of actually tests to be done. So Splinter actually gives you a very nice, way to use. This is how simple it is to actually run an end-to-end test using a browser, etc. If we had to check if the front end is also working, if it has the right components, yada yada.
Would you put that into a Lambda function, or you would do like a type test, different stage? What do we do?
I think if I were to run a Lambda function, then I would run another project which is awesome called Chromeless, which actually use Chrome in a headless way, and you could also run that into Lambda function. Someone already did all the compiling stuff, etc. Because I'm more comfortable with Splinter and also PyTest Selenium, I would just use this, not having a Lambda function, and I would do a new build spec file called build-spec.integration task, for instance.
Right.
And then I would extend my pipeline and say, run code build again after you deploy in beta, gamma, and prod.
Absolutely. Okay.
So that's how I would do it.
So that kind of summarizes everything together, how to build a pipeline, how to do unit testing locally, how to deploy that into your code pipeline project. If you had to deliver 3 key takeaways from this session, what would that be to the people that are watching?
Sure. First, it would actually be try the new SAM CLI, not only the init command, but actually the validate and everything else that we now provide to you. So if you probably missed this, there's a lot that should be in there.
Right.
Second, code build local makes life so much easier because all of this iteration, we couldn't have been waiting for code pipeline to kick in with all of these pieces. It takes a while, so it kind of it slows you down.
Absolutely.
So in this place, it actually makes so much faster the entire experience. And lastly, integration tasks don't stub or don't create false. You don't use false services in order to test the integration, etc.
Sure.
Because the contracts could be different and they're not going to have all the features.
Okay.
And especially in servers, you're only going to pay for what you really use. And if it's idle, you're not paying a damn thing.
Right.
So
okay.
That's what I normally recommend. If I were to do that in practice, I would even start from here. I would say, let's say, so I can finish this episode. I could say clean slate.
Okay, I like that.
So I could go in here and say, subinit, Python, name of my project, start from here.
Awesome.
But I like to go more advanced. I would use my advanced project. So for now, do this, right? I have my Python project in here.
Right.
I have my template YAML, which is necessary for me to get started. I have my requirements.txt, my application, and I have all this stuff in here.
And a test directory structure to get started.
I have very similar to what we just saw it.
Awesome.
But now I don't have any pipeline. I can now just run subinit -- location, that URL that I gave to you, and you can say, this is going to be my new Python app. And I could use whatever, I could just code commit again, and now if I open up a new Visual Studio Code or whatever I do, now I have everything to get started again much more quickly. Exactly. Okay. And I could even go further. I could go and try using Cloud9, which already have SAM CLI and SAM init, SAM location.
Yeah.
Boom.
Gotcha.
You get this stuff out of your way and improve your development workflow.
I think I'll give Code Local a go, actually.
Yeah, you should. You should.
After watching you, I think I'll give it a go.
Yeah. Sure, absolutely. So if you are beginning with code build, there is this very nice little script if you're on a Mac or on a Linux, you can run this script. That basically all you need to do is specify some flags and you say what image you want to run, if you want to include AWS configuration, like the profile type credentials. Okay. And you don't need to memorize this kind of a Docker run -v, but yada, yada, yada.
All right, okay. Absolutely. Yeah, that's actually a really good thing to get started. I'll have a look for sure.
Perfect. So that's it, really.
All right.
Thank you for watching, everyone. Thanks for helping us, especially when we've had some little roadblocks.
Yeah, so some in the chat were actually saying you forgot the quote, so people were...
That's pretty cool. So this is what I like. I kind of say this is a live Stack Overflow. You don't really know what you're going to get into.
Yeah.
And they also should prove that we're doing this live. Sometimes, the brain doesn't work that long. Thanks for watching. This episode is going to be available on YouTube in a couple of days. We do have a playlist for all the episodes, including the programming serverless bites from Christmas, who's a star in the serverless scenario, and all of his episodes, including all the build on servers, the advanced pieces, are there. We've done Java already. We've done some Python. We're gonna do .NET very soon, and then Go will follow right next.
All right.
And then Node.js is also coming, but that's just to kind of tease you a bit what's coming in the next episodes.
All right, awesome. Can't wait, actually. And yeah, thanks for showing me all these things. I'll get cracking, I guess, right?
Absolutely. Awesome. See you guys in the next episode. Thank you, everyone, and have a great day.
Thank you for watching.